clear?
No, no. It's everything is clear.
Okay, okay. So can you able to introduce yourself with your total experience and don't reveal about your genuine experience? Tell me your fake. So this is the DevOps mock interview day 27. Okay, we already completed 26 mock interviews. If anyone watching from YouTube, right, please go and check out the 26 mock interviews. Okay, today Power Talks is going to participate in this mock interview. If I get 27 likes, right, as it is 27th mock interview, if I get 27 likes, definitely I'm going to update 28th mock interview in the YouTube. If I don't get, we are not going to update. Yeah, please introduce yourself.
Yeah. It's myself, and I have a total 5 years of experience and senior DevOps engineer.
Okay,
And we have currently working the current project and CI/CD pipelines and Jenkins, Docker, Kubernetes, Terraform. We are
okay,
using these tools on our project right now.
okay. Compared to last time, right, you performed very well in this mock interview. Okay, do one thing, just share, like text me your experience and your on which tools you are perfect. So mention your tools which you know well first, remaining tools last, so that I will generate some script. Okay, I will share you that script. You need to practice that in front of mirror. In the next mock interview, whenever I ask you introduce yourself, right, you need to remember that script and you need to uh, what you need to present that. Okay,
Your voice is okay. Okay.
okay. Am I audible? Hello.
Yes.
Okay, is there any disturbance from my side? No, right?
Yes. Yes.
Any disturbance?
No.
Oh, that's great. So
No
yeah,
disturbance.
okay, without wasting, let's start today's mock. Okay, I will share my screen. So first question will be, how do you manage storage in Kubernetes? Right? That is one part. How do you manage storage in Kubernetes? And what is the difference between persistent volume and persistent volume claim? Okay, how do you manage storage in Kubernetes? And what is the difference between persistent volume and persistent volume claim? In every interview, this is a damn sure question. Without this, no interview will going to have. Do you know? Yes or no?
No, don't know.
Anisetti Power Talks.
No.
Okay, Akash. Hello. Akash, do you know what is this persistent volume and persistent volume claim? Okay, normally, whenever we create any pod, whatever present inside the pod, what will be having? Container will be running, right? Inside the container, if you want to preserve the data, we will use persistent volume and persistent volume claim. Okay, these things I will, anyway we will discuss after few minutes the answers. Okay. Yeah, Sunil. Uh,
Yeah,
like how do you manage storage in Kubernetes? And what is the difference between this persistent volume and persistent volume claim? Sunil, do you want to try this?
okay, sir.
Do you know about this? What is persistent
To
volume, persistent volume claim?
Kubernetes, I just want to work on this.
Okay, you don't know, right?
No,
Super, no issues. Second question, how does Kubernetes handle multi-container pods? Nothing but in one pod, if you have two containers, how Kubernetes handle that? And when would you use sidecar container? One thing was, how does Kubernetes handle multi-containers? If you are running multi-containers in a pod, and when you should use multi-container, nothing but a sidecar container. Anyone want to try it out? Anyway, the answers will be discussed after few minutes.
The Cube scheduler will schedule the containers to the different pods, so
Super.
it will
Yes.
distribute.
Yes, you are right. So anyone watching this video in YouTube, please like this video. If I get more likes, we are going to continue this series. Okay, anyone want to try? Thanks, Harish, for your answer. Next question. How do you handle configuration changes in live Kubernetes environment, nothing but production environment, without downtime? Okay, there is some configuration changes I need to apply inside my Kubernetes live environment. That too without any downtime. How do you handle that type of changes? This is also real-time scenario-based interview question. I will show you the answers. Okay, you no need to worry about it. But if you want to try, even if it is wrong, it's okay. It's a learning for us. Okay, silence. I will make it as you don't know about it. Let us continue to fourth mock interview. So explain how Kubernetes handles scaling pods based on custom metrics, not other than CPU and memory. Okay, we are using request and limits. Not I'm asking about CPU and memory usage. Other than that, how Kubernetes handles scaling of pods. How pod will scale automatically other than CPU and memory. Without using the CPU and memory metrics, what is the other approach?
Sir, using replica sets.
Replica set will manage pods.
Oh,
I am
okay.
talking about the
Kubernetes
scaling
scaling.
of pods.
HPA is
Super,
okay.
you are right. Horizontal pod autoscaler. Using horizontal
Auto.
pod autoscaler, we can able to scale.
Yes.
Right. Next question and final question for this interview. What happens if a Kubernetes master node fails? How do you design a resilient control plane? Nothing but if you have a single master Kubernetes cluster, right? If it is fail, so in order to troubleshoot next time, you should not get that type of issues. At that time, how you will design a to maintain the resilient control plane? Anyone? Simple, like for suppose
Bo-
if Kubernetes master node fail, what will happen? Answer this. Just imagine there are Kubernetes master and nodes. My master got failed. In the background, what will happen? What will happen to your running pods for your deployment? What will happen?
The deployment will get fail and
Okay. Where your deployment will be running?
in nodes, in
So
containers like.
in nodes, but here the master is
Yeah.
failed, right?
Yes.
But how your pod going to fail? Because your pods will going to run in node. Your master
No.
was failed. Okay, shall we check the answers for all the questions?
Yes.
Yes.
Okay. So first question, how do you manage storage in Kubernetes? What is the difference between persistent volume and persistent volume claim? In Kubernetes, storage management is essential for stateful application. What is stateful application? Database. Database related pod need to preserve the data or not? Obviously, we need to save our data. So first one was persistent volume. So what is persistent volume? Persistent volume is nothing but a storage resource in the cluster. Okay, it is independent of any specific pod. and is abstracted from underlying storage system, example NFS and cloud based block storage. Nothing but in AWS we will be having volumes or not, EBS volumes, yes or no?
Yes.
We can use that volumes as a volume for our Kubernetes. Okay, and it is independent, yes or no? It is independent of any specific pod. Even my pod was failed, my volume will be deleted from my AWS, no, right? It is running on independently. If I delete that volume, then only it will be removed. So what I can do, I can use EBS or EBS volumes as a storage for my pod. How I will use that? Using persistent volume. Anyway, if you are learn DevOps, right, these things already discussed in my classes also. I have already discussed. If you are only enrolled for the project, right, so you need to be expert in this persistent volume. Okay, how pod will get a volume? Using PVC. Okay, what is persistent volume claim? A persistent volume claim is a request by user for storage. So it binds to a specific persistent volume that matches the storage criteria. Nothing but the PV is the actual storage and PVC is a claim for that resource. Simple real life example. Do you use mobile data daily?
Yes, sir.
So what we are doing, we are requesting 2 GB daily. Okay, for your mobile number. You are requesting a 2 GB for whom? To the provider, internet service provider. Yes or no?
Yes.
So Airtel or Vodafone, whatever it may be, they are providing our a internet for us, internet service provider. They call it as the internet service provider. We are requesting. So in the same way, pod will request for storage. How it will request? Using a PVC. Okay. But actually, who is providing storage? PV will provide a storage. You got it right? PV is the actual storage. We are requesting the storage using PVC. Okay. Why we are doing all this? I can directly attach PV to my pod, right? Because if pod got failed, just imagine you pod got failed and if PV is attached, it is stuck or not. That's the reason in between we have a link PVC. If pod got failed, okay, your percent volume will be removed because you are using PVC. Here pod is requesting for the storage. So once the pod got failed, your percent volume will be available for another pod because here there is no direct link to the percent volume. It will be a little bit confusing, but don't worry. Simple thing. PVC using PVC you will claim. Now simple real life example. You have like purchased a insurance. You will claim that insurance. Yes or no? You are paying an amount yearly like 15 to 20,000 per year for your health insurance. Something happens if anyone for X person, he will claim that. Yes or no? Here same like that itself. For pod required a storage. What pod will do? Pod will claim that using a concept called as persistent volume claim. For whom? From persistent volume. How this persistent volume will be created? Using some cloud storage or elastic EBS. You got it right? Shall we continue to next? Yes or no? Okay. How does Kubernetes handle
Yes.
multi-container pods and when would you use sidecar containers? So in Kubernetes, pod can run multiple containers. These containers share same network, same resources, but each container runs independently. Okay. In Kubernetes, a pod can run multi containers. Okay. In the pod, you can have multiple containers. That's what it is telling. These containers share whatever the containers running inside the pod will have same network and same storage. but each containers will run independently, even though if they have same storage and same volume, sorry, same network, they will work independently. Multi-container pods. Multi-containers in a pod are usually tightly coupled and need to share resources or communicate closely. An example could be logging agent container, sidecar running along an application container. Okay, there is an one container will run. Another container will be sit behind that and it will collect the logs of the container. You are getting my point? There are two containers. One will be main container, another will be sidecar container. What sidecar container will do? Sidecar container will collect the logs of the main container. You are getting my point? For that purpose, we can use multi containers. You are getting my point? If you want to collect logs of one container inside a pod, you can create one more container beside that container in the pod. You can collect the logs. Sidecar container is a secondary container that enhances or supports primary application container. Use cases includes logging. A sidecar container can collect logs from the primary container and send them to log accelerator aggregator. Or sidecar container can act as a reverse proxy such as service mesh patterns. Nothing but reverse proxy, nothing but it can able to manage the traffic. So next question will be, how do you handle config changes in a live Kubernetes environment without downtime? So handling configuration changes without downtime is critical for ensuring high availability. Here are few strategies. Config map and secret. Store application configurations in config maps are secret. When you update a config map or secret, Kubernetes automatically mounts the updated data into the pod, though not all applications reload them dynamically. So if you use config map and secret, right, even though if you apply to the pod, it doesn't happen. Changes will not like changes will be applied, but there will be no downtime. Okay, when you update a config map or secret, Kubernetes automatically mounts the updated data into the pod. Automatically, whatever you have done, it will update it in the pod. Okay, rolling updates. Nothing but you can use the rolling update feature as well for application that do not dynamically reload configuration, performing a rolling update by updating the deployment with a new config values. So automatically what rolling update will do, slowly it will terminate the old pods and it will replace the new pods without downtime. Yes or no? This will gradually replace pods with the updated configuration without downtime. Yes or no? Am I right?
Yes, sir.
Yes.
Yes.
So one was rolling update, another one was config map and secret, another one was graceful shutdown. Use pre-stop hooks or and liveness probes to gracefully terminate the old pods while the new pods are being rolled out. Okay, what liveness probe will do? Liveness probe, what is the use of liveness probe? It will try to restart, right? If something happens, it will try to restart. So you can use liveness probe to terminate the old pods. Explain how Kubernetes handles scaling pods based on custom metrics other than CPU. So nothing but a HPA, horizontal pod autoscaler. Kubernetes supports scaling pods based on custom metrics using the horizontal pod autometrics. Here how it works. In addition to CPU and memory, we can define custom metrics such as request rates, queue length, or response times, or trigger autoscaling. So the metric server provides basic resource metrics like CPU and memory. To use custom metrics, we need to deploy a custom metrics adapter, example Prometheus adapter, that allows HPA to query custom metrics from external monitoring system. Example, we can if you use Prometheus, right? What Prometheus will do? Prometheus will enable these features using some custom metrics rather than CPU and memory. Other than CPU and memory, you can use Prometheus. So you configure the HPA. This is the example horizontal pod autoscaler deployment file, like manifest file. So if you see API version autoscaling, kind horizontal pod autoscaler metadata name spec. Inside this, you can mention the deployment, minimum replicas, maximum replicas. This one we already discussed in Kubernetes classes. So metric HTTP request per second. Target will be value will be 500. So external metrics can come from external systems like Prometheus, Datadogs, etc. While collect application specific metrics, and these are used for scaling decisions. So depending upon your metrics, you can able to scale and scale down. Use that too using Prometheus. So what happens if a Kubernetes master node fails, and how do you design a resilient control plane? Explanation: Kubernetes relies on the control plane to manage the state of the cluster. If the master node fails, the cluster ability to schedule new pods and process changes is impacted. Nothing but you cannot able to schedule a new pod. Okay? If a single master node fails, the cluster may become read only. Existing workload will continue to run, but new deployment, scaling, and configuration changes will be blocked until the master node is restored. You got it? Harish, you got it? You
Yeah,
cannot
got it,
able
got
to
it.
schedule the new deployment, but your pod will be keep on running. Nothing will happen to your pod.
Okay, okay, okay.
So high availability, multi-master setup. What you can do if the Kubernetes master node fail in future, if you don't want to get that failure, you can use horizontal, right, HA proxy. You can set up HA proxy, horizontal autoscaler. Okay, multi-master setup. Nothing but you can maintain the multiple Kubernetes masters. To avoid runtime and single point failure, you can run multi-master nodes. Okay, in that way you use horizontal autoscaler. You need to configure that. Okay, ensure as a more than half of etcd store node must be running. Ensure consistent. Nothing but you need to maintain the etcd as well, and that etcd should be maintained, and more than half of etcd nodes must be running. Your etcd should be in running state, that to more than half of. And backup and recovery: regularly backup etcd which stores the cluster state. In case of failure, restoring the etcd backup can help in recover the cluster. Okay, whatever you do, everything configuration will be stored in etcd. So regularly take the backup of etcd. That's what they are mentioning. Use a load balancer in front of API servers to ensure requests are balanced across healthy master nodes. Okay, this allows the cluster to continue serving. Okay, this is what. Okay, you got it right. I will stop the recording.